Hello everyone, welcome to part 2. We're just continuing some stuff with exponent rules, and sometimes these fractions are these exponents are fractions. So let's get to it. This question I have right here, a lot of it's going to be stuff that we've done before with just regular fractions. In terms of like sometimes we have variables with exponents and other times it's just a regular number. So if it's just a regular number, simplify that like normal. What number goes into 10 and goes into 15? You know, the greatest common divider. And the answer is 5. 5 goes into both of them. So if you divide them both by 5, you get a 2, because 5 goes into 10 twice, and 5 goes into 15 3 times. And then you have this x to the 5 halves, y to the third, x to the 1/2, y to the 5th. So let's concentrate on the x's right now. This is division, and with division you are supposed to subtract the exponents. So 5 halves minus 1/2. Very lucky they have the same denominator. They're both over 2. So you can just subtract them. 5 halves minus 1/2 is 4 halves. So you would have x to the 4 halves, which we'll simplify in a bit. 3 minus 5. 3 minus 5 is negative 2. So you can either put y to the negative 2 up top, or there's the trick that we've talked about, at least in my videos, that if you compare exponents, wherever the bigger number is, that's going to be where the y is. So since 5 is bigger, y squared is going to be in the bottom, which is exactly what would happen if you put y to the negative 2 on top. It would flip to be y squared on the bottom, because of negative exponent rules. Either way, like I said, we're going to simplify that. 4 over 2 is just 2. So you get 2x squared over 3y squared. No radicals because there's no rational exponents. There's no fraction exponents. 14, as I like to call it, the hot mess problem. I guess I'm going to get rid of this negative 2 part first. The negative is going to take everything and flip it upside down, and then I'm just going to multiply all exponents by 2. So when I do that, I want to make sure all my things have exponents. This has an exponent, this has an exponent, this has an exponent. The 3 has an exponent of 1. The z has an exponent of 1. So to save time, I'm going to multiply all exponents by 2. And since these are fractions, maybe I'll think about it as a 2 over 1. And at the same time, I'm going to flip it upside down. Well, maybe I'll do that later, make it less confusing. Okay, so 3 to the first, but the 1 is being multiplied by negative 2, right? This negative 2 is being multiplied to all the exponents. So it'll be 3 to the negative 2, x to the positive 4, z, 2 times 4 is 8, so this will be negative 8 over 5, and r to the 0 times negative 2 is just 0 again. X, 4 times negative 2 is negative 8, and z to the negative 2. All right, so this 3 to the negative 1/2, 3 squared is 9, so you're going to end up with a 9 in the bottom. R to the 0 is just 1, so that just goes away. Here we have a 4 and a negative 8. You subtract them, so 4 minus a negative 8. 4 minus a negative 8. 4 minus negative 8. Turns into a plus, so you get 12. So x to the 12. And that deals with the x's. As for the z's, oh boy, negative 8/5 minus a negative 2. Subtract the exponents. Negative 8/5 minus 2. It will become a plus, but because it is adding, you have to get a common denominator. And right now this 2 is over 1, while this one is over 5. So to get a common denominator, the common denominator is going to be 5. So what do we have to multiply by? 5 on top and bottom. So we get negative 8/5 plus 10/5. 2 is equal to 10/5. So then negative 8 plus 10 is 2, and it just stays fifth. So the new exponent for z is 2/5. And it's positive, so it's going to be up there. That's the answer. Isn't it beautiful? Don't answer that. Next up, simplifying some expressions by converting. Okay, so let's convert to rational exponents. Hopefully this is getting faster for you. This is a third root. Since it's a third root, it's 5 to the 1/3. This has no number, so do you remember if there's no number, what number it is? A 2. So this would be 5 to the 1/2. Since we are multiplying, we have to add the exponents. 1/3 plus 1/2. The common denominator, do you know what the common denominator would be? Because I know what the common denominator would be. Both of these numbers go into 6. So you'd multiply this one by 2 over 2 to get 6, and this one by 3 over 3 to get 6. So you would get 2/6 plus 3/6. So then 2 plus 3 is 5/6. So the answer is 5 to the 5/6, I believe. Yeah, okay. It doesn't say we need to make it into a radical again. If it did want it as a radical, it would just be the 6th root, because the 6 is in bottom. Like that. And maybe you have to multiply that out, I don't know, but we're not going to, because it's a huge number. 16. 16 is super fun. This root 7 here is the same thing as 7 to the 1/2, correct? Of course it's correct. Why would I be saying it if it's not? So the square root of 7 is equal to 7 to the 1/2, because it's a square root. Now, since this is a third root, you can take the 7 to the 1/2 that we already had there, and then use this third root to say that this thing is to the 1/3 power. Right, is a third root, so it's to a 1/3 power. And now you would multiply these exponents. And with multiplying exponents, you do not need a common denominator. It would be 1 times 1 is 1, and 2 times 3 is 6. And if it wanted it in radical form, it would be that. Oh boy, I have so many problems I wanted to do. I got 99 problems, and radicals are 90% of them. All right. Multiplying, oh my. Actually, we don't need to do a problem like that, come to think of it. These are practice problems that I put just to see if you were able to. I'm going to do them very quickly, so just pause the video, see if you can do them. And then I'm going to do them very quickly just so you can check your answers. Okay, the 7 is 7 to the 1st. So it is going to be 7 to the 1/10 and x to the 3/10. This is a square root symbol, so this is going to be 5 to the 1/2 and x to the 1/2, all to the 4th, right? Because it's a square root. And then you distribute this 4 to both of them. So 4 times 1/2 is 2, and 4 times 1/2 is 2, and 5 squared is 25, so you get 25x squared. Actually, it just says rewrite it, never mind. So you could probably have just left it like that and been okay, but I did all that because I like math. Rewriting, this is a fifth root of x to the 4. This is going to be a square root of 10 to the first, which is the same thing as just the square root of 10. Doing it again. I need to back it up. All right. Simplifying, once again, I'll do them real quick. I would pause and try them. Just these three. Since this is an x to the first, you would have to do x to the 1 minus 2/9. To do 1 minus 2/9, you would have to get a common denominator. So you would make this a 1 over 1. And you'd have to multiply this one by 9 over 9. So you'd get 9/9 minus 2/9. 9 minus 2 is 7. So you'd get 7/9. So x to the 7/9. That is it with rational exponents. If it says to put it in radical, then because the 9 is on bottom, it is going to be a 9th root. And then you got this x to the 7. All right, here we're going to distribute this to both of these exponents. We'll get x equals to the negative 5/10. 1 times 5 and 5 times 2. And then y to the 35 halves, because this is like a 7 over 1. This simplifies to x to the negative 1/2, y to the 35 halves. Since this is negative, it'll go to the bottom. So y to the 35 halves over x to the 1/2. And since these are halves, that means they're going to be square rooted. So you get the square root of y to the 35 over the square root of x. And that's good enough for what we're doing now. Square root, because it's a 2. Anything to the 0 is just 1, so that just cancels out. Distribute this 2, you get z to the 2/4 and y to the negative 6th. Feel free to pause and look at it or rewind if it's too fast. Z to the 1/2 over y to the 6th, which is the same thing as the square root of z over y to the 6th. Okay, I'm stopping there. The next video is going to be on radicals and no more rational exponents. We're going to have some fun. Peace.